Last class we talked about multiplying and dividing and simplifying rational expressions, and today we're going to talk about adding and subtracting rational expressions. I'm going to try to make this as quick as possible because it's 11:30 at night. Here goes. All right, so adding and subtracting rational expressions is a little bit more complicated than multiplying and dividing rational expressions, and that's because if you think about it, adding and subtracting fractions, if I had a divided by b plus c divided by d, well, I have to have a common denominator and I don't. So I'd have to multiply this side by, d over d, and this side by b over b. Remember, multiplying by d over d is the same as multiplying by 1. I'm not changing the value here, I'm just changing how it looks. And I'd end up with AD over AB, or DB, sorry, bleh, plus CB over DB. And then I can add them. And I don't add the bottoms, I keep those the same, I add the tops. So I'd have AD plus BC over BD. I'm putting them in alphabetical order. It's kind of anal, I know. Okay, so the same thing applies when you're adding rational expressions. You have to have a common denominator, and then you add the tops or subtract the tops. Okay, so for the first example, I have two rational expressions that I'm going to add together, and you can see here that they do not have the same denominator. I could just multiply this term over here by x minus 4 over x minus 4, and this side by x plus 2 over x plus 2. But by the time I do that, it's going to, if that's not my lowest common denominator, this is going to get big and ugly pretty quickly. So the smart thing to do is you want to factor first. Oh, okay, so this is already factored, but this is the difference of two squares, and I can factor that into x plus 2 times x minus 2. Okay, now you can see that this side is only lacking the x minus 2. It has the x plus 2. So I don't have to go crazy and multiply by x squared minus 4. Well, I might go a little crazy, but... And now I have a common denominator. And now I'm going to multiply this top out, and I get x squared minus 2x. And then I can go ahead and combine this minus 8 over x minus 2 times x plus 2. And if I re-multiply that out, I get x squared minus 2x minus 8 over x minus 2, x squared, where's that eraser? Minus 4. Pretty easy, right? Oh, I almost forgot. I forgot my domain restrictions. If you look here, x cannot equal plus or minus 2, or the whole thing is undefined. Okay, here's one for you to try. Pause the video, start it back up when you're ready to check your answer. Okay, hopefully you factored your denominators correctly and you ended up with x minus 4 and or x plus 4 and x minus 1, and then you could see that you only needed to multiply this side by this side over here by x minus 1. That's what I have here. And then you could multiply this out, or not. Combine the top, multiply it out, and simplify. In the end, you should have ended up with 2x squared minus x minus 3 divided by x squared plus 3x minus 4. And you can see from the very top up here that x cannot equal negative 4 or 1. All right, let's try a subtraction. Okay, I have a common denominator, so that's good. This is going to be a lot easier. If I didn't, I'd have to make a common denominator. What I have to be careful with here is the subtraction. I'm subtracting this whole term on the right-hand side. So I have to protect, there actually are implied parentheses around the top and bottom of every fraction. You don't see them, but they're implied. So I have to put those around it so that I remember that I'm going to need to distribute that. Okay, and I'm going to go ahead and do that now. 3x squared minus 4 minus 6x minus 1 divided by x squared plus 1. Oh, by the way, if we look at our domain restrictions, if I set that equal to 0 and tried to find my domain restrictions, I'd get x squared equals negative 1, and then I'd get x equals plus or minus the square root of negative 1. So there are no real domain restrictions here. Just thought I'd add that in. Okay, let's combine our like terms. 3 minus 6 will be negative 3x, and negative 4 minus 1 will be negative 5. Still have x squared plus 1. Here's my final answer. All right, I have one for you to try. You might find this a little bit more challenging because you have to remember you have to have a common denominator. So pause this, complete the problem, start it back up when you're ready to check your answer. Okay, let's give this a shot. Get my pencil out. Okay, over here I have x squared minus 9. If I factor that, that is the difference of two squares. I have x plus 3 and x minus 3. Here I have my minus sign, so be careful. You have to distribute that to the top. And you can see here that you're missing x minus 3 over here. So you need to multiply the top and the bottom by x minus 3. All right, we'll rewrite that. We get 2x squared minus 30 minus x plus 5 times x minus 3. And all of that is over x plus 3 times x minus 3. All right, let's go ahead and FOIL out the right-hand side of that numerator. That would be x squared plus 2x minus 15. I'm going to go ahead and recombine that denominator. All right, let's see if we can simplify the top a little. 2x squared minus x squared is going to be just x squared. Let's get rid of those so I know I've used those already. If I distribute this negative sign, I get negative 2x. Let's get rid of that. And the negative sign distributed to the negative 15 is going to be positive 15. So negative 30 and positive 15 are going to be negative 15. And that's my final answer. This is undefined. Go back up here at plus or minus 3. Okay, one more type of problem to solve. That is again complex fractions, which I can just rewrite as a division problem. Now's a good time to look at the domain restrictions. X cannot equal 1 and x cannot equal -5. Okay, I can reciprocate now and multiply. And I end up with x plus 2 times x plus 5 divided by x minus 1 over x minus 3. And you can see that I do not have any common factors, so I can't cancel anything out. So all I can do is combine, and I get x squared plus 7x plus 10 divided by x squared minus 4x plus 3. Done. Your turn. Try this out. Pause the video. Start it back up when you're ready to check your answer. Okay, hopefully you noticed up here that you needed to combine that before you could rewrite this as a division problem. All right, so I need to have a common denominator up in this numerator of my complex fraction. I have an x in this denominator and I have a 2 in this denominator. That means that I need to multiply the left side by 2 over 2 and the right side by x over x. Okay, so that's going to give me 6 over 2x plus x squared over 2x. I'm going to go ahead and combine this into a one fraction. So I get x squared plus 6. I'm putting the 6 on the right hand side just because I like descending order. Okay, now I can reciprocate this and write it, or actually I'm going to write it as a division problem first. If you take a look at this, what can x not equal? Well, if it's 0 here, that's undefined, and if it's 0 here, that's undefined. So x can never equal 0. All right, now we can write it as a multiplication. All right, and you can see that I don't have any common factors here or here, here or here, but if you look across, I have an x I can get rid of. And that leaves me with x squared plus 6 in my numerator and 2 times x minus 1. These x's here canceled out. Combining everything again, I get x squared plus 6 over 2x minus 2. Complete. That's it. Have a good night, or actually it's not night, it won't be nighttime for you. Well, maybe it will. Anyways, have a good weekend.